hypotenuse. The adjacent side to 30 degrees is radical 3. This is 2. Hypotenuse. The hypotenuse doesn't change. When you get tangent, that's opposite over adjacent. I left it as 1 over radical 3. I probably could have converted this to radical 3 over 3, but this is fine. 60 degrees, now it's opposite over hypotenuse. That's why sine of 60 degrees is this. Cosine of 60 degrees is adjacent over hypotenuse. So now so for 60 degrees, this is the adjacent side. This is still the hypotenuse. That's why we get this. And tangent, again, opposite over adjacent. So I'm not sure if those proofs really made sense. I mean, I hope they did. But again, I'm just trying to illustrate why sine of 30 degrees is a half, why cosine of 60 degrees is a half also. You know, we're not making this up arbitrarily. I mean, it turns out these equations have to hold. That's all I'm trying to say. And here we get the other functions as well. I mean, you could actually get them from the values of sine, cosine, and tangent. The cosecant's 1 over sine. I'm going to go back and forth like this, but cosecant's 1 over sine, right? So 1 over sine, 1 over a half is 2. Likewise for secant, that's 1 over cosine. So the corresponding cosine value, you just invert. So if you turn this upside down, you get this. That's all. I mean, what's nice is these are also programmed in your calculator. Although the radical 3 part will become a decimal, depending on the calculator you have, but that's okay. All right. I'm just trying to show you where these numbers come from. That's all. What's nice is, with our calculator as well, we can actually figure out all the unknown side lanes of a right triangle. Remember, this is why this is one of the reasons that trig is so useful, is you know one angle besides the 90-degree angle, and you have a side. You can get the other 2 unknown sides. The previous proofs illustrate how you actually would get sine, cosine of a specific angle. What's nice is we don't have to remember those numbers. They're in our calculator. I mean, how do they know sine of 37 degrees is what it is? I honestly don't know, but it would have to be a proof like what we saw, or some other kind of trick. All right. Anyway, the sine of so if we want to get A, right? What do we have? We have A is our opposite side, right? We know 40, which is the adjacent side. So the question is, to find A, what would we use? We have opposite, adjacent, right? We have opposite, adjacent. Well, what trig function involves opposite and adjacent? Tangent, right? So to get A, we can use tangent. Right? Again, by SOHCAHTOA, I didn't write it out, but if you did write it out, you would see that tangent is opposite over adjacent. We are solving for the opposite. The adjacent is what we know. So that's why I'm doing this. Okay, so now how do we get A? Well, we want to isolate it, right? So what do? We want the 40 out of there. We can multiply both sides by 40. And that's what I'm doing here. Now for the next one, this should be 37 degrees, not 40. Let's fix that. I missed them. Again, that I did in my calculator. So make sure when you do this in your calculator, you're in the right form. Excuse me, you're in the right mode. You want to make sure you're in degrees. If you're in radians and you type in tangent of 37, the calculator is going to think you want tangent of 37 radians. but it's 37 degrees, okay? You want to make sure that's right. So you want to make sure you're in the right mode. Okay? I know the iPhone, you can go between radians and degrees. I know you can do that. So basically, once we do this, we have, wait, what's that laser thing? Here we go. So once we do this, okay, right, now we just do 40 times this, and rounding the 4 decimal places, we get this. That's what we get. Okay, so again, this is illustrating really, why triggering is so useful. If you know the angles, notice that if we have this, since we have this angle and this angle, we know this one. And we know one side length, we can get the others. Okay, we know what A is now, an approximation. We theoretically could get C using Pythagorean's theorem, right? But for fun, let's not use Pythagorean's theorem. If I wanted to get C now, right, I'm going to use cosine. Now you might be thinking, well, why are we using cosine? Well, notice that we know 40, right? We know what 40 is, okay? That's the adjacent side. But now C, hypotenuse. So we're not going to use A. We're not going to use Pythagorean's theorem, in other words. So if we know what the adjacent side is, and we're looking for the hypotenuse, of course, we're going to want to use the trig function involving adjacent and hypotenuse. That's cosine. I mean, if you tried the other trig functions, you would see they would involve A. Sine, cosine, or tangent, that is. Sine or tangent, that is. Cosine involves the 40 and the C. That's what we want. Remember, we're not using A here. We're not using Pythagorean's theorem. So we have this. Now we have to figure out what C is, right? Well, now it's just basic algebra. Again, most of the work is done. This is really the hard part. Although I guess you have to figure out how to get this from the calculator, the cosine of 37 degrees, but I did say that already. All right, so basically from here, I'm going to cross multiply. And basically we solve for C. You know what? I might, since we're low on time, I might go through this one again next time. Let me just see. Yeah, well, we got 30 seconds left. I don't want to rush. Well, I really don't want to rush through it. So let me just stop.